Hello friends, very good morning. In today's video, we are going to learn the development of the lateral surface of a hexagonal pyramid, which is cut by two section planes, out of which one of them is horizontal and the other is inclined to the horizontal. And they have given us the position where exactly they cut the solid. So let's go through the problem of today's video. The question reads like this: a hexagonal pyramid of side 30 mm and axis 60 mm long, resting on its base on HP with an edge of base normal to VP. So there is a hexagonal pyramid which is placed on HP such that one of the six base edges of the solid is normal to VP. So we can complete the position of the solid by placing it on HP such that an edge of the base is normal to VP and obtain the top and front views of the pyramid to the given dimension. So I have completed or drawn a hexagon here representing the top view of the base with O, the vertex, joined to all the corners like A, B, C, D, E and F. And every side measures 30 mm. Here OA, OB, OC, OD, etc. represent the six slant edges of the pyramid in the top view. So taking a height of 60 mm and by projecting all these lines, we obtain the front view, the triangle O dash, this is A dash, B dash, this is E dash, D dash, and this is C dash, F dash. This is O dash and this is O1 dash. O1 dash is the center of the base. We will mark O1 here. So we have completed the front and top views of the hexagonal pyramid to the given dimensions. Next friends, next comes what is called drawing the development. So before that, you will have to mark the section planes. And as I told you before, there are two section planes which are cutting the solid. One of them is horizontal and cut the pyramid at a distance of 20 millimeter from the base. So here this line represents the base and I will just mark a line here at a distance of 20 millimeter from the base and call this as section plane 1 1. So I'll call it as S1 S1 and this is at a distance of 20 millimeter from the base A dash B dash A dash D dash. That is section plane 1. Very obviously this is perpendicular to VP and it is parallel to the base. Likewise friends, we have the second section plane which is cutting the solid at a height of, it is inclined at 40 degree and cuts the axis at a distance of 20 millimeter. So friend, I have to take a point here on the axis and draw a line passing through that, and that line is inclined at an angle of 40 degrees to the horizontal. Say this is the line we have got, 40 degree. This is our section plane S2, S2 and this again at a distance of 20 millimeter from the vertex, at a distance of 20 millimeter from the vertex. So we have drawn two section planes. And next comes what is called the portion that is to be retained for the purpose of development. We have been asked to draw the development of the portion between S1 and S2. That means this part. So I will show that part in visible line. So this is the part which is to be retained for the purpose of drawing development. So this part, we'll call it as part P. Now friends, next we have to move on to drawing the development of a solid. Friends, if you observe the top view, none of these slant edges are parallel to XY and hence none of these slant edge O dash A dash to O dash F dash give you the true measurement of the slant edge, because you know very well all the developments are drawn to the true size or the actual size. What I do friends, to get the true length, I write a horizontal line through this O. Now taking O as center, this distance OD as radius, I am going to draw an arc. That arc will meet the locus of O here. Then I move that to the XY line and join that to the vertex, and this line which I am showing by dotted line will represent what is called the true length of the slant edge. So you have to make use of this true length, and we draw a vertical line here of length is equal to true length, that is O dash, this distance, this can say D1 dash. O dash D1 dash is the true length. Again I am going to write a sector here, taking O as center, this distance as radius. I have written an arc, on that I have marked 6 steps, each having a distance of 30 millimeter, 30 each, like that. So friends, this is the development of the hexagonal pyramid when it is not cut by any section plane. Now friends, this is being cut by two section planes. So one is horizontal. So let us take up the development by taking S1 first. The section plane S1 is parallel to the base. So all the slant edges, all the 6 slant edges are cut at the same height from the base, and none of them are true length. So I am going to shift this to the last line, the true length line, take that measurement, that is the measurement on OA, OB, etc. So before that we can have this marked as ABCD, ABCD, E, F and G. These are the 6 points on the base. Now I am going to mark this distance on all these. So friends, that can be done by taking center O and radius equal to this distance and draw an arc first. So we will have an arc drawn here. This is parallel to the base. Now friends, all are cut at the same height. So I can very well join all these points on those slant edges by straight lines. So this is the points 1, 2, 3, 4, 5, 6 and 1 because of this point. Next friends, we have got this inclined section plane also cutting all the slant edges, that is all the 6 edges. So we'll have to take all of them one by one. So to start with, S2 is cutting OA and OB here. This is not the true length. So shift that to the last true length line. Take that on OA and OB. So on OA and OB, I am going to take that measurement. So on OA, on OB, again on OA. So I have marked this point. Next, OC and OD are cut here. They are also not true length. So shift that to the last line, that is true length line. Take that on OC and OF. So on OC, I just take this point. On OF, again that point. Finally, the last line, namely OE and OD are cut here. It is also not true length. Shift that to the last generator of the slant edge. Take that measurement on OE and OD. So I will take them here, OE and OD. So friends, again, as you all know, the points so obtained are to be joined by what is called the straight lines. So OA, OB will have the same measurement, OA, OB and OA, right? OC and OF will have the same measurement, OC and OF. These are the points you have got. Join these points by straight line. Friends, I have joined all the points so obtained by straight line, and here the part between these two section planes is this one. So I have to show it dark, and all this portion in between the section plane is to be shown by visible lines or dark lines. Friends, this is what the development of P, the part between the section plane S1 and S2. and all other lines here should be shown by thin lines. Again, the portion above that should be shown by the thin lines. Friends, I hope you like the video, and please go through the complete video. At the end of the video, if you like this video, do share this information about my video and also about my YouTube channel link, namely Engineering Drawing and Machine Design by Dr. MHA. Thank you for watching my YouTube video. Have a blessed day.